Hey everyone! In today's video, we're going to talk about classes in Python, what they are, why they exist, and how you can actually use them in real code without feeling confused. Now, before we touch any code, I want to slow things down for a moment and talk about the idea behind classes, because once the idea clicks, the syntax becomes much easier. At the most basic level, a class is simply a blueprint. That's it, a blueprint for what an object should look like and how it should behave. Think about something simple from real life. Before a company manufactures a car, they don't just randomly start welding metal together. First, they create a detailed design, what the car will look like, how fast it can go, how it starts, how it stops, and what features it has. That design comes before the car. In programming, a class is that design, and the actual car you drive is the object. So for this lesson, let's imagine something a bit more interesting. Let's say we are building a music streaming application, and we want to model a speaker. Before we can create actual speakers, we first need to define what a speaker is. That means what information does it have, what actions can it perform. And that's exactly what a class helps us define. In Python, to create a class, we use the class keyword followed by the class name. By convention, class names use Pascal case. That means the first letter is uppercase and every new word also starts with an uppercase letter. So if you had a class called Smart Speaker, both words would start with capital letters. In our case, we'll keep it simple and call the class Speaker. For now, the class will be empty. And even though this class doesn't do anything yet, something important has already happened. We've created a blueprint. Because now that the blueprint exists, we can start creating actual speakers from it. This process is called instantiation. So let's say we create a speaker called JBL. So we write a variable named JBL and assign it to speaker. Those parentheses are very important. The moment you put parentheses after a class name, Python creates a new instance of that class. That means this is now a unique speaker created from our blueprint. At this point, we have a speaker object, but if we try to print it, what we'll get back is not very helpful. We'll see something like a memory address, basically Python saying, yes, this object exists and here's where it lives in memory. That's normal. But as you might notice, this speaker is completely useless right now. It has no information, no behavior, no functionality. So let's fix that. The next concept we need to understand is the initializer. The initializer is a special method that runs automatically when an object is created. In Python, this method is called dunder init. You'll notice it has double underscores on both sides. That's why it's sometimes called a dunder method. The purpose of dunder init is simple. It allows us to pass information into the object when we create it. So let's think, what information should a speaker have? At minimum, maybe a brand name and a volume level. So inside the init method, after self, we'll add brand as a string and max volume as an integer. Inside the initializer, we then assign these values to the object itself by writing self.brand equals brand and self.maxVolume equals maxVolume. This step is extremely important because without self, the data wouldn't belong to the object. It would just be local variables that disappear. Now, as soon as we do this, Python will tell us something. It will complain. Why? Because now our class expects extra information when we create a speaker. So when we instantiate speaker, we must provide a brand name and a maximum volume. So we'll update our code and say brand is JBL and max volume is 100. And just like that, our speaker now contains real data. We can verify this easily. If we print jbl.brand and jbl.maxVolume, Python will return the values we passed in. Now we don't just have a speaker object, we have a customized speaker. We can even create another one. Let's create a second speaker called Sony. Same blueprints, but with different data. Brand is Sony and the max volume is 80. And if we print Sony's attributes, we'll get Sony's data, not JBL's. This is the power of classes. One blueprint, multiple independent objects. Now at this point, there's usually one question every beginner asks. What is self? And that's a very good question. Self simply refers to the current instance of the class. When we create JBL, self becomes JBL. When we create Sony, self becomes Sony. It's how Python knows which object you're talking about. One interesting thing, and a lot of beginners don't know this, is that the name self is actually just a convention. You could technically rename it to anything and the code would still work, but please don't do that. Every Python developer expects this parameter to be called self. If you change it, your code becomes confusing to read. So yes, you can change it, but you really shouldn't. Now that our speaker has data, the next question is obvious. Can it actually do anything? Right now, it just exists. So far, we've created a speaker class, and we've given it some data, like brand and maximum volume. But right now, our speaker doesn't actually do anything. It just sits there. In real life, a speaker isn't useful unless you can turn it on, turn it off, and play music. So let's give our class some behavior. And in Python, behavior is added using methods. Before we write any methods, we need one more piece of information. We need to know whether the speaker is currently on or off. This is called state. So we'll go back into our dunder init method and add a new attribute called isOn. By default, when you buy a speaker and take it out of the box, it's turned off. So we'll set this to false. Now let's write a method that turns the speaker on. Inside a class, a method looks just like a function, except it must take self as its first parameter. So let's add a method called turnOn. In here, we first check if self.isOn is already true. If it is, we don't turn it on again. Instead, we simply print a message that says the speaker is already turned on. If it's off, we flip the state to true and inform the user that the speaker is now turned on. This prevents accidental or duplicate actions, which is exactly how real systems work. Now that we've written the turnOn method, the next obvious thing we need is a way to turn the speaker off. So inside the speaker class, just below turnOn, I'm going to create another method. I'll call it turnoff. Since this is a method inside a class, the first parameter again has to be self. And this method isn't returning anything, it's just changing state and printing messages, so the return type will be none. Now, before I write any logic, let's think. What happens if someone tries to turn off a speaker that's already off? That shouldn't really do anything, and we should probably inform the user instead of silently failing. So the first thing I want to check is the current state of the speaker. We already have that information stored in self.isOn. If self.isOn is false, that means the speaker is already turned off. Now in this case, I don't want to change anything. I just want to let the user know what's going on. So I'll simply print the message. Now let's think about the other scenario. What if the speaker is currently on? In that case, turning it off actually makes sense. Inside this else, we need to do two things. First, we update the internal state of the speaker by setting self.isOn to false. And then, just like before, we'll print a message so the user knows what happened. This is exactly how we want real-world behavior to work. And because this logic lives inside the class, every speaker we create will automatically behave this way, without us having to rewrite this logic again. Alright, so now our speaker can turn on and turn off, which is good, but it still doesn't really do what a speaker is meant to do. So the next thing we want is the ability to play music. For that, we're going to create a new method inside our class. So let's go back inside the speaker class, and right below turnoff, we'll define a new method. We'll call this method playMusic. Now, since this is a method inside a class, the first parameter always has to be self, because we need access to the current speaker instance. And then we'll take one more parameter, let's say seconds, which tells us how long the music should play. Now, let's think about the logic before we write code. Can a speaker play music if it's turned off? Obviously not. So the first thing we should check inside this method is the state of the speaker, whether it's on or off. And we already have that information stored in self.isOn. So inside the method, the first thing I'll write is an if condition. Now, if the speaker is on, we want to simulate music playing. Since this is just a learning example, we'll simply print a message that will say which brand is playing music for how many seconds. But we're not done yet. What if someone tries to play music while the speaker is turned off? That's a mistake, and instead of crashing the program, we should handle it. So we'll add an else block and simply print a message like, please turn on the speaker. Now let's actually use this method and see it in action. Below the class, we already have our speaker instance, so let's call this method using dot notation. So first, we will call the turnOn method twice, and then we call the playMusic method and pass 30 seconds. And then we call the turnoff method, and one more time we'll call the playMusic method. So now when we run this, we will first get the speaker turning on message, then a warning when we try to turn it on again, then we get the playMusic message, and then finally the speaker turning off message. And at last, a warning when we try to play music while it's off. This is object-oriented programming. So at this point, our speaker class is actually useful. It has data, state, and behavior. Now I want to show you something interesting. Let me try to do something that looks reasonable, but will actually fail. So down here, outside the class, I'm going to print JBL plus Sony. Now, if I run this code, Python immediately throws a type error, and that makes sense. Python has no idea what it means to add two speakers together. We never told it how to do that. So how do we fix this? This is where dunder methods come in. Dunder is short for double underscore, because these methods always have two underscores before and after the name. You might also hear people call them magic methods. These methods tell Python how should this object behave when someone uses a certain operator. So let's go back inside our speaker class. We're going to define a method called dunder add. This method is automatically triggered when we use the plus operator. The method takes self, the current speaker, and other, the other speaker. This method says when someone adds two speakers together, return a string combining their brands. Now, if we run this again, this time there's no error. Python sees the plus, looks for dunder add, finds it, and executes that method. That's it. Now that you've seen one operator, adding another is easy. Let's say we want to support multiplication as well. So again, inside the class, we define another dunder method called dunder mul, and this will simply return the string multiplication of brands. Same idea, different operator, different dunder method. Now let's talk about something very practical. Right now, if I just print JBL, what I get back is a memory address. That's not very helpful, so let's fix that. Inside the class, we'll define the dunder str method. This method tells Python how should this object look when someone prints it. Now, when I print JBL and Sony, I get something clean and readable. This is called the string representation of the object. So why should you care about all of this? Because dunder methods let your objects work naturally with operators, integrate cleanly with Python's syntax, behave like built-in types. This is one of the reasons Python feels so expressive. All right, so with that, we've reached the end of this video. Today, we covered the fundamentals of classes in Python, how to create a class, how to add data using the initializer, how objects maintain their own state, how we add behavior using methods, and even how we can customize object behavior using dunder or magic methods. If you're just starting out with object-oriented programming, don't worry if everything didn't click instantly. It's one of those topics that starts making more sense the more you actually use it in real projects. There is still a lot of important concepts left to explore. Things like inheritance, encapsulation, polymorphism, and abstraction. And these are extremely important if you want to write clean, scalable, and maintainable Python code. So if you'd like me to continue this series and cover the remaining object-oriented programming topics, let me know in the comment section down below.